universe always increases in entropy. Um, and so, if you think about the system consisting of our sun and the planet Earth, um, the sun is a fusion reactor. It's taking 4 hydrogen atoms, forming 2 deuterium isotopes, and making a single helium. Now, the mass of the helium is less than the mass of the 4 hydrogen atoms that went into the reaction, so that mass defect is distributed or radiated from the sun in the form of energy. That energy takes the form of light and heat. Radiation, so to speak. And so, of course, the light from the radiation from the sun is not just visible light. There's also ultraviolet radiation, which is damaging, can cause skin cancer. And so the life forms, the humans that evolved, developed a mutation. The mutation was increased melanin, and that increased melanin mutation ended up being a successful or appropriate for equatorial regions of the planet, which receive dangerous levels of ultraviolet radiation. And so folks with melanin, the Africans and the Indians, are resistant to developing skin cancer. Whereas the white folk, their skin will turn red in the tropical regions. So, anyway, but we're talking about entropy. And so the sun is a continuous explosion. It's a fusion reactor. The temperature and pressure conditions are sufficient at the core of the sun for fusion to take place due to gravity. And so the explosion that is the sun is continuously bursting outwards, but the mass of all the particles in the sun is such that the explosion is retained. And so basically, gravity is such that the temperature and pressure at the core is sufficient for fusion to undergo, but gravity is also such that that explosion is retained, and the sun's shape is roughly spherical. So, if you were to assess the entropy of the sun, it would be extremely high. The level of disorder of the sun is extremely high. And so we are the third planet orbiting the sun. And if you were to assess the entropy of us, highly organized carbon-based life forms, or the entropy of a tree, which is also highly organized, organic life form, you would find that the entropy of things on the planet Earth is low. And so given that, the universe always increases in entropy, all of the order that exists on planet Earth is only possible because the disorder of the sun exceeds the order on planet Earth. And so let that sink in. The disorder of the sun exceeds the order on planet Earth. Right? And so, unfortunately, because the universe always increases in entropy, you get the following scenario as to what the future will look like. You get that basically our sun, which I believe is a kind of a average main sequence kind of star, at some point in time, 500 million to 1 billion years from now, it will become a red giant. And that is because it will start fusing not just hydrogen, but then helium and lithium and so on, heavier elements all the way up to iron, until it becomes somewhat unstable, the radius increases, and it becomes a red giant. Now, around this time, which is 500 million to 1 billion years from now, Earth will no longer be in the Goldilocks region around the sun, and the sun will have evaporated all of the oceans on planet Earth. In which case, if humans are, planning to still be present as conscious entities in the universe, we would have to be elsewhere. We'd have to have expanded the scope and scale of consciousness to elsewhere, further out into the solar system. Ultimately, maybe even a completely different star system. However, you get the following scenario. So, if you want a quick lecture as to how black holes form, you get the following. So, basically, a star, around the time it's exhausted its fuel and it's experiencing instability, it starts to collapse in on itself. And then when it collapses in on itself, depending on certain things, after the initial collapse in on itself, the star explodes outwards in a supernova. And so there are different types of supernovae. And so, after that supernova explosion, there's a remaining massive object that I believe may be, depending on the mass of the star, a neutron star or some kind of white dwarf. Now, if the neutron star is sufficiently massive, the neutron star will collapse in on itself all the way to a singularity. And so, basically, at that singularity, there is not any space or time. And so if you understand visually general relativity, where space-time is like a sheet, massive objects are like funnels that sort of curve space-time. And so a black hole is pretty much like an infinitely steep funnel in space-time. And so basically, the thing about it is that while the event horizon of a black hole may be large, the black hole isn't actually the size of the radius of the event horizon. It is actually just the extremely tiny, infinitely dense singularity, right? And so what is causing the apparent event horizon radius is because, sort of, given the mass of the black hole, it's going to be such that the escape velocity is exceeding the speed of light a certain distance from the singularity, right? And so the light can only escape at a point where the curvature of space-time is such that the escape velocity is less than the speed of light. And so escape velocity is basically the speed you need to reach to escape the gravitational pull of an object. And so if the escape velocity is greater than the speed of light, light cannot escape. If it's less than it, light can escape. The event horizon marks the point at which the escape velocity equals the speed of light, given the mass of the black hole. And so as the universe increases in entropy, you have the following scenario. All the stars of a certain mass will eventually turn into black holes. And so the stars that are not massive enough to turn into black holes, and maybe you have these remnant white dwarfs, which are just duds, right? However, the rate of supposed new star formation from like clouds of hydrogen is not going to be faster than the production of black holes, so to speak, from dying stars. And so as the universe increases in entropy, the actual end of this thing is that pretty much the entire universe is just black holes and there's nothing in it, right? Which is really heavy. It's like, oh Jesus, the whole simulation is increasing in entropy. The end of it is just the entire universe is just black holes. It's like, oh shit, that's heavy as fuck. It's like, okay, we're we need to leave the planet Earth before the sun turns into a red giant. But even then, there's going to come a point where if humans try to live infinitely in the universe, everything is just black holes. It's like, oh shit, we're just screwed. So, but anyway, anyway, there's a recent upload that has the title Hexagon with all capital letters and with a space character between each of those letters. And so I'm playing, there's Hexagon, Hexagoner, and Hexagonest. Then there is the hyper mode for each of those levels. And so I'm playing Hexagonest hyper mode, and I last for 60 seconds in the sort of white and gray level, which is, that level. Anyway, and so after you get to that level, you get to the highest possible level. Sorry, after you last for 6 seconds, after you last for a minute in that white and gray level with a gray background and white obstacles, you get to the highest possible level, which is just a black background and white obstacles. And so I was recording, fortunately, when I did this, but I kind of beat my record. I lasted for 150 seconds overall, 60 seconds in the gray and white level, and then 90 seconds in the black and white level. And so the music, the angelic music, in the black and white level is surreal. It feels like you've like reached the maximum possible uh, you know uh, stage of the experience. And so I lasted so long in that final black and white level that the soundtrack actually started again from the beginning. And so that 150 seconds with 90 seconds in the black and white level, you know, was a record for me, and I was fortunately recording while it happened. But the thing is that, in relation to what I've said previously, that um, black and white level goes on forever. Goes on forever. And so you never beat the game. You must die at some point. And so that final black and white level, gets me thinking about the whole thing of, with the increasing entropy of the universe, that the entire universe is eventually going to be black holes. And so even if humans live on to the end of the universe, right, it's just going to be a bunch of black holes, at which point, I can't predict, as to how science would have advanced to that point where we could somehow live in a universe in which everything is just black holes. But it seems like, no matter what, you have to die at some point. What kind of civilization can exist in a universe which is only black holes? I'm not so sure. I'm really not so sure. So it seems like at some point we're just gonna die. So anyway, but and so Super Hexagon and that final, black and white level gets me thinking about, black holes and shit. But anyway, so this is just my thoughts on, like, some basic astrophysics and so on and so forth. But anyway, the other thing is, of course, in movies, you get you get quite nice movies. So I think it was Zathura, which may involve some kind of black hole thing. And I believe that in the movie Zathura, the concept of spaghettification is touched on, where basically black hole's gravity is so intense that, if an object has some length, the strength of gravity at one end of the object is greater than at the other end, such that that object is elongated or stretched. And so this is what happens. So yeah. Then of course Interstellar, they have the black hole called Gargantua. And Gargantua is basically, you have the final scene where they do a very, uh, you know, uh, sort of risky maneuver where they go quite close to the black hole, um, and then Cooper detaches to let Dr. Amelia Brand, uh, you know, be shot to the other potential habitable world. And when they are that close to Gargantua, of course, there is time dilation. And so, when you are close to a black hole, because of Einstein, general relativity, you are actually aging slower than the rest of the universe. Slower than the rest of the universe. And so there you are, close to the black hole, orbiting it. You are barely aging, and the rest of the universe around you is getting old. So, general relativity has been confirmed, even in experiments with objects orbiting or subject to Earth's own gravity, and it is correct. But the problem is that a black hole is an object in which general relativity applies, but the singularity is an object in which quantum mechanics should apply. And so, in the search for a theory of everything, the answer is a black hole. Because a black hole, the singularity is such that the object is quantum mechanical, but the gravitational field and space-time distortion is akin or analyzed with general relativity. And so if we could unite our understanding of quantum mechanics as applied to the singularity that is the black hole, and then general relativity as applied to its distortion of space-time, you would have a theory of everything. But that's really hard to do. And so theorists have gone and developed, after quantum mechanics, there's quantum field theory, which is at high energy. And then, of course, there is 11-dimensional M theory, which was what Hawking was working on sometimes. And then, of course, there is string theory. And so in 11-dimensional M theory and string theory, you have the following. You have 3 typical spatial dimensions, 1 time dimension, and then 7 smaller curled up spatial dimensions. And I believe that you may you may get into needing to use mathematical manifolds in relation to this. But anyway, yeah. Um, I studied undergraduate level quantum mechanics. And so this was covering Heisenberg uncertainty. Um, and so basically the uncertainty in position multiplied by the uncertainty in momentum is less than h bar over 2. Um, which means that if you know the position with precision, you cannot know the momentum with precision. If you know the momentum with precision, you cannot know the position with precision. And then, of course, there's a Schrödinger equation in one dimension. Wave functions which are complex valued. And expectation value calculations for different observables, be it position or momentum or the like. And then there's quantum mechanics in 3 dimensions, applying that to a hydrogen atom or something. Schrödinger equation in 3 dimensions, expectation value calculations for observables in 3 dimensions, linear algebra notation. And so on and so forth. But one of the most profound things about quantum mechanics is the following experiment. If you have an electron gun and you have a double slit, which is a material consisting of 2 slits, and you fire those electrons out of the electron gun one by one, they're going to go through both of those slits, right? But even though the electrons are being shot one by one, the electrons are described by a probabilistic wave function. And because that is true, that probabilistic wave function interferes such that at your detecting sheet, you will see a wave interference pattern build up over time, even though the electrons are being shot one by one. A wave interference pattern with a central maximum and the like. And so why in the heavens is that happening? Well, because no one is looking at the electrons. And so when no one is looking at them, they're just described by a probabilistic wave function. When there is conscious observation in this experiment, the electrons will precisely follow a straight line coming from either of those 2 slits. And instead of a wave interference pattern at your detecting sheet, you will simply see 2 streaks correspondent to the positioning of the 2 slits. And so hence the universe is such that conscious observation collapses the wave function and makes the particle's position determined. And so the black hole, the singularity, is an object small enough for quantum mechanics to apply, but massive enough for general relativity and time dilation to apply. Now, the intelligence that created our reality is smarter than us. And so intrinsically, if it so desired, it would set things up in such a way that we could never know certain things. And that's exactly what it's done with a black hole. Indeed, the intelligence unfortunately said, you will never know certain things. So this has been Deus Ex Machina. Subscribe to the channel.